third line that's thrown in here. So when you have in geometry, not so much algebra quite yet, when we have diagrams to show that things are parallel, we draw arrows on lines. Where we did with tick marks to show that things were congruent, here we just put these little arrows on them because then that shows that things are going to be parallel. Guys, I would recommend getting some paper out, writing some stuff down. I've seen some of the stuff that I just created and they kind of suck for a lot of part, and I can tell who's doing what and who's not doing what. You might want to put away phones, unplug your earbuds, and draw some pictures. Go figure, you might do better in school. Just saying. So, excuse me. Again, those arrows denote the fact that something is, in fact, what we call parallel. In algebra, when things were parallel, when you had graphed things, will those lines ever intersect? No. Algebraically, why don't they intersect? Remember the reason? What do they have in common that makes them parallel? Well, are all lines straight? Very good. Same slopes. Parallel lines are known to they'll have same slopes. The idea of slope, we're not going to worry about that quite yet, but towards the back half of this chapter, we bring back in writing equations of lines with slopes and intercepts and things like that as well. The third part of this diagram is this guy here. This is something new. This is a new term that we're going to use. It's called the transversal. A transversal, and I just learned this today from Mrs. Thrower. When she taught, or actually when she grew up in her schooling, they talked a lot about what were called Latin roots. Most of the English language can be traced back to Latin text, and Latin has, just like in Greek, there's certain prefixes that mean certain things. Well, transversal means roughly translates, I forgot what it's called. Roughly translates cut through. Okay, trans goes through. Trans means across, and then versal means cut. Think of it, transatlantic, you go across the Atlantic. Transcontinental railroad, you go across the continent on a railroad. That kind of stuff. Here, this being transversal means a line that cuts through two or more other lines. Now, granted, it could look like this. Here's a line here, here's a line here. This could still be a transversal. It still works the same, but for our purposes, the more specific we get is when the lines are parallel, because then certain things occur. So we usually just go right into straight parallel. Yes, sir? Yeah, we're in. Okay, let's leave the door open so we can get back in. Now, one of the things that we did previous chapter is that we talked about when two lines intersected. I hope that vaguely rings a bell. It wasn't that long ago, right? We learned about angle pair relationships with two lines. We knew for our example here, let me say I do this. I label this 1, 2, 3, and 4. If I just number those angles 1, 2, 3, and 4, give me a set of angles that are congruent. 1 and 3. Why are 1 and 3 congruent? What's the angles there? Remember? Help them out. 1 and 3 because they're what? Vertical. Very good. We know that 1 and 3 have to be the same because they're vertical angles. Remember, vertical angles were angles that shared a vertex whose sides create lines. Okay? And then that also meant that angles 2 and 4 were the same. Is that because of the same reason? Now, what changes today is that we have one line and another line that are parallel to one another. When those lines are parallel and you have this transversal that goes through them, for all intents and purposes, the easiest way to look at it is that these angles just get replicated on the next line. Okay? Those angles get replicated. So instead of having 4 angles, now we have a total of how many? 8. So what I do is this. I just start relabeling 5, 6, 7, and 8. Let's move this out of the way for right now. Oops. Oh, hello again. Thank you, sir. You can just look that way. Yes, I appreciate it. So are we okay that we have 8 total angles now? Now, here's the thing. When you have this thing, when you have these parallel lines, you guys ever heard of an if-then statement? Yes. What is it? Yeah, perfect. Cause and effect. That's very good. Very good way of looking at it. So what we get is a giant if-then statement. Now, we can write it out as if 2 parallel lines are cut by a transversal. Oops. No, you see what I'm saying. It's transversal. That's a lot of words. Oh, I'm sorry. You guys are okay with me using parallel for that? The slashies? That just stands for parallel. Okay. That's a lot of words. Well, math, if you guys haven't figured out, we're lazy. We use symbols all the time. We use abbreviations. We do a ton of things. There's an abbreviation for all of this, and it looks like this. That symbol stands for all of those words. It's easier to write that symbol than it is to write out those words. Am I right? Pretty easy. Let me ask you this real quick. Why can't you do this? They don't continue going on, but do you know what this symbol means? Not equal. Yeah, exactly. It means not equal. So that's why you have to put the little arrows on it. All right. This means not equal. All right. So what we do in geometry is we do a ton of if-then statements, cause and effect, like you were just saying. What'd you forget? Sure, man, just help yourself real quick. When you're going through these things, all we got to do when you're doing this cause and effect, if this occurs, then something else is going to happen. And then in this case, what happens is we get what are called angle pair relationships. So those 8 pictures you guys just saw, those 8 pictures had a representation of what we call different angle pair relationships that occur if 2 parallel lines are cut by transversal. They have definitions and very, very easy things to work with. For example, first one we talk about something called corresponding. You might have heard that before, haven't you? Yes. Corresponding angles. If I'm thinking about this thing called corresponding angles, I'm going to draw my little picture off to the side, put my little arrows on it to show that they're parallel. And I have that. If I label it like that, angle 1 is in what position on that top line? What would you say that is? If I'm looking at the top line, this is just those 4 angles. Angle 1 is in what spot? Top left, isn't it? What other angle on this line is top left? 5. What angle corresponds to angle 8? What angle corresponds to 6? 2. So we're going with that. Corresponding angles are angles that are in the same position. Angles in same position on same side of the transversal. Okay? They're same side, same position. Now, if we start putting some numerical stuff to this, you'll even see more things that'll happen. So, if I say that this angle is 110 degrees, what does the angle that's next to it have to equal? 70, because the two of them are supplementary, they're linear pairs, so it's got to be 70, right? What does this angle down here have to be? Which makes the angle over here. Okay. Now, if these angles correspond to one another, and the lines are parallel, these angles are always going to be congruent. So that makes 110 in the top left. That also means the top left of the other line has to be 110. Which means this one has to be, which means this one has to be, and then back over. Notice the relationship, vertical angles, linear pair, linear pair, linear pair. Even the ones that are next to each other on the inside are a linear pair, because they're next to each other. Any angle that's next to itself, next to another one, they're always linear pairs, or supplementary. Okay? I can't say those two on the inside are a linear pair because they're not touching the same vertex. But whenever they're next to each other, they're always going to equal 180. Okay? So that's our first one, corresponding. I bet you've heard the next one. I didn't even write it down yet. Alternate interior? You ever heard of that? It's probably been a while. I don't know how far in depth any of this stuff you guys go into in regular algebra off the first one. So when you have parallel lines, transversal, as I'm going through there, alternate interior. Well, alternate. Take a guess what that means. They switch, right? Alternate, when you alternate, you switch. Interior. What's another thing for interior? Well, that's the opposite. In. Inside the lines, opposite sides. 4 and 6. 3 and 5. They are opposite sides of the transversal between the lines. 4 and 6. See how they're in between the lines? On opposite sides. They alternate the transversal. They're in between, they're on the inside of the lines. And look at our numerical example on the whiteboard. If I look at the angles I have in the position of 4 and 6 over there, aren't those both 70? Oh, that means they're what? They're congruent. Alternate interior angles. When lines, again, back to your cause and effect thing. If two parallel lines are cut by a transversal, we get corresponding angles congruent. Alternate interior. If we have alternate interior, what else do you think you have? Alternate exterior. Gee, I wonder what those are going to be. 1 and what? Yeah, 1 and 7 and excellent, very good. Alternate exterior. It's the same definition. Opposite sides of the transversal on outside of lines. And lo and behold, they are also congruent. 1 and 7. 2 and 8. Walking through definitions. Gee, had you known this stuff, you might have been able to do a couple of those problems we did at the beginning of the class, right?
Wait, what's that?
Oh. No, and some of those were linear pairs. Yeah, that's not right all the time. But remember, it's okay. It was just, did you know any of this? If you knew something, cool, you knew something going in. But did you know the specifics? No. But are you learning them? It's crazy how math works, isn't it? It's like I've always said to people, I never taught you how to add or subtract, multiply, divide, but you still use it all the time with all of this stuff, don't you? It just builds upon itself. Okay, everything just builds. That's kind of how math works. All right. And then the last one is kind of the weird ball. The last one is called the same side interior. Same side interior. What do you think same side stands for? The same with the fives? So what are you thinking? 4 and 5. Yeah, excellent. 4 and 5, and then 3 and 6. They're same side inside. You're inside the lines on the same side. Same side inside. You're here, and you're here. Same side transversal. Between the lines. There is not a same side exterior. Thank you for asking that. No one asked that in the other classes. There is no such thing as same side exterior. Okay? There is no such thing. Now, if you look at our numerical example, what can you tell me about same side inside here? They equal 180. What about on this side? Same thing, right? So if the two things add up to equal 180, what are they? Supplementary. Very good. So same side interior angles are always supplementary, which means they add up to equal 180. Okay. Now, when I say always, I'm talking about when the lines themselves are parallel. That's kind of the big kicker in this stuff. If the lines aren't parallel, a lot of the math part, as far as the numbering, doesn't really work. The relationships are still there, but they don't necessarily add up to specific values. That's why I kind of skipped 3-1, because why not just jump right to the more important stuff? So let's see, same side interior are supplementary. Okay. Well, this is all great and all, but what is this going to allow us to be able to do? Well, what happens here then is we can get to a picture and if I say that this angle here is 63 degrees, I know enough information to figure out all of the angles. Yes. Here's how we do this every single time. And I make this as blatantly obvious as possible, because if we can make it super simple and we replicate it all the time, you guys will fall through this real quick. So here's what I do. I always start in the top left, and I put a tick mark for the angle, and then I go to its vertical, because I know that those two have to always be the same. I switch sides of the transversal on the inside, which means I'm using the alternate interior, and then I do one more vertical. I know for certain, every single one of those angles with the red tick mark will all be equal. Did I run into the 63-degree angle? Nope, not at all. So that means every angle that I didn't touch has to equal how much? 63. Every single one of those has to be 63. So there's 63, 63, and 63. Notice again, these two guys are corresponding. Same side, same position. Corresponding, same side, same position. Alternate exterior. Opposite sides on the outside. Opposite sides on the inside. Which means all the red ones have to be 63s somewhere. Which means we just subtract 63 from, and what do you get? 72. There you go. That makes all these guys 117. So if you don't know how to start a problem, every single time do the same thing. Tick mark, vertical, alternate interior, vertical. And if tick marks match, great. If they don't, you know how to send them through. Now I made a bunch of these on pictures so you guys don't have to continually draw them so you get the copy of it real quick. Sorry. No problem. Here's the ruler of walking. Now, in this case here, I'm looking at the front. You guys okay if I call on this side the front? Because it says where your name's at usually. I've got the hole punches. I forgive me. I normally would hole punch it. You know, front's always where the holes are on the left, but whatever. So I'm looking at the front one here, and I want to switch over, and I'm going to go to number. Let's see. I'm going to go to number 8. And I'm going to show you how this works as you would do this in homework or on worksheets or on anything like this at all. The problems itself said to solve for angles 1 and 2, but what I want to do is just kind of fill in the whole thing. So I do the same thing over and over and over again. Tick mark, vertical, alternate, vertical. Do those match up to the angle that they gave us? Yeah, which means every single one of those tick marks has to equal how much? 56. Could we make this any easier? All right. What do all the other ones have to equal then? Which is? Very good. All the rest of them would be 124. Now, could I have gone through those others where the 124s are at and done double tick marks the whole way through? Yeah. The only thing is that the reason I don't do that is because it kind of looks like crap when I do it because my handwriting is not that great. So that's why I say if it shares the tick mark, we know that they're always going to be the same. Which means all the 4 that don't share, that don't have a tick mark would be the same. And if they have a tick mark and don't have a tick mark, they're always going to be 180, no matter what. It always works. Okay? Go to 10. Let's look at 10. Same thing. Oh, wait. Before we get too crazy here. Same deal. I'm going to start that top left, vertical. What do all 4 of those have to equal then? Oh, wait. Very good. Because it tells you so. Which makes everything else 172? 72. It's okay. What happens if one of those angles is a right angle? It's It's 90, but what about all the other 7? They're all 90. If one angle is 90, do the same thing. That means everything that has a tick mark would be 90. I'm just saying, it'll either say 90 or it'll give you that little box. Basically what happens is if you get one box and you've got 2 parallel lines, everything's 90. Look, because the actually really easy example of that, yeah, look, if you look at your lined paper, you got the blue lines going left and right, you got that red tab line going up and down. That red tab line is perpendicular to every single one of those blue lines going through, which means every one of those angles is 90. This is 24 different parallel lines cut by one giant transversal with all those congruent angles. Math. Now, look at the difference between that one and 13. What's different with the picture on 13 versus the ones we've been doing?
13.
Yeah.
It's twisted, isn't it?
Yeah.
What would you do to your paper to make it look like everything else we've been doing? Pace yourself. I don't want you to sprain anything.
Just leave.
Can you just do that? Just turn your page. But now, when I do it that way, I can mark it the same way I have been, haven't I? Change your perspective to make it look like something you've been doing. It sounds silly, but just that twist of that page a couple degrees off the side, it makes everything a lot easier to see. Okay? I've done this once or twice. I know a trick or two, which means every one of those angles has to be the same. Did I run it at the 95-degree angle at all? No, which means that every one of the red marks that I made has to equal how much? 85, very good. All those, because these two will always be supplementary, because they're next to each other. The 95-degree angle of this guy always forms a linear pair, so you just subtract it from 180. And then every other angle then has to equal 95. That's the idea. We just change the page, change the perspective of what you're looking at. Yeah. And then it'll always be the angle next to it. They always create a linear pair. They always do. Yes, ma'am? If they're next to each other, yes. These two angles next to each other will always add up to be 180 every time. These two angles next to each other will always be 180 because they create a line. This, well, we'll get there. Same deal. We'll flip it over real quick. If I look at 17, and all I'm going to do to start this problem, I'm going to spin it. I'm just going to turn my page. As soon as I turn my page, now it looks like what we've been practicing with the lines going left to right. Once those lines go left to right, then I can just mark it because it's quicker. Those two angles match up, don't they? Which means they have to be congruent. Which means algebraically, what do we do? 80 plus. They have to be equal. Remember, these things means they're equal. So that x plus 15 is 80. Use the tick marks as you follow through the diagram to see if they match up. If they match up, they're equal. Very good. You get 65 for x. Very good, very good. All right. All right. Take a look. Why don't you guys try 19 on your own real quick? Try 19. Do the same thing. Follow the tick marks. Mark it.